Let us look at an example of discounted payback period method. Assume the following cash flows for two projects. So we have been given the cash flows for project S and project L. So today, or at the beginning of the tenure, the investment outlay for project S is 1000 rupees. So these are all in rupees. And similarly for project L, the initial investment outlay is 1000 rupees as well. And then at the end of year 1, project S gives a cash inflow of 500 rupees, whereas project L gives a cash inflow of 100 rupees, and so on. Assume that the cash flows are occurring at the end of the year. Find out the discounted payback period for these projects if the cost of capital is 10% for both the projects. So here the cost of capital has been given as 10%. In other words, the time value of money is 10%. So here S stands for short and L stands for long. Project S is a short-term project which will give benefits in the short term, while project L is a long-term project which will give benefits in the long term. Let us quickly draw the timelines for these two projects. So on the screen you can see the time scale for both the projects, project S and project L. Now, since the initial investment is as of today, we should bring all these other cash flows to a value as of today. So basically this 500, we should find out what will be the value as of today. Similarly for this 400, what is the value as of today, and so on. Similarly for project L also, we have to find out the value of these cash flows as of today. And the discount rate for both the projects is 10%. So let us start with project S. So as shown, I have put the year and the cash flow for project S in this table. Now, as we had seen on the timeline, we have to find the present value of, let's say for the first cash flow, which is 500 rupees. So this is 0, this is 1, this is 10%. Let's say the present value for the first year is PV1. Now, this will be a case of compound interest where the present value is PV1, the future value is FV1, and the rate of interest is 10%. So we know that future value in compound interest is equal to present value into 1 plus I to the power n, where n is the number of compounding periods, I is the rate of interest per compounding period, PV is the present value, and FV is the future value. So PV is equal to FV divided by 1 plus I to the power n. So let's calculate the values for the discounted cash flow for each of these cash flows. So PV1, that is the present value for the cash flow in the first year, is equal to FV1 divided by 1 plus I to the power n1. Future value is the value which we are getting at the end of that year. So in this case is 500 divided by 1 plus I is 10%. So 10 divided by 100, this will be 0.1. N1 is 1 because this is being compounded or discounted for 1 year. So this becomes 500 divided by 1.1, which is equal to 454.5. Similarly, PV2 is FV2 divided by 1 plus I to the power n2. This is equal to 400 divided by 1 plus 0.1 to the power 2, because this is being compounded for or discounted for 2 years. So this is 400 divided by 1.1 square, which is equal to 330.6. Similarly, PV3 is 225.4 and PV4 is 68.3. Now, since we have to find out within how many years we'll be able to recover the original investment, we have to find out the cumulative cash flows at the end of each year, so that we come to know how much do we have in hand at the end of that year. So at the end of first year, the cumulative is the same, which is 454.5. At the end of the second year, the cumulative discounted cash flow will be the addition of the discounted cash flow at the end of the first year plus the discounted cash flow received at the end of second year. So 454.5 plus 330.6, which is 785.1. At the end of the third year, the cumulative will be the addition of the cash flows received during the first year, second year, and third year. So the cumulative discounted cash flow at the end of third year becomes 1010.5. Now, if we don't want to add the cash flows for these 3 years, we can also do the calculation by adding the cumulative received at the end of second year plus the cash flow received during the third year. Similarly, for the fourth year, 1010.5 plus 68.4, which is 1078.8. Now we know that the payback period can be found out using the formula years before full recovery plus unrecovered amount at the start of the period divided by cash flow during the period. So let's find out years before full recovery. So we want to recover the initial investment of 1000 rupees. So at the end of second year, we have a cumulative discounted cash flow of 785.1, and at the end of third year we have a cumulative discounted cash flow of 1010.5 rupees. So basically we will recover the 1000 rupees during the third year. So the years before full recovery is 2, so this is equal to 2 plus, now unrecovered amount at the start of the period. So unrecovered amount will be 1000 minus 785.1, because we have already recovered 785.1. So the unrecovered amount is 214.9. And then cash flow during the period. So cash flow during the third year is 225.4. So 214.9 divided by 225.4. So this is equal to 2 plus 0.95, which is equal to 2.95 years. So we'll be able to recover the entire investment outlay of 1000 rupees in 2.95 years for project S as per the discounted payback period method. Now let's do the same calculation for project L. So as you can see on the screen, I have noted the cash flows for project L received at the end of each of the 4 years. I have also found out the discounted cash flow for each of the years at 10% discount rate. And then I've also found out the cumulative discounted cash flow. Now, as we know, the payback period is years before full recovery plus unrecovered amount at the start of the period divided by cash flow during the period. So the initial investment outlay for project L was 1000 rupees. So we have to recover this amount. Now we are recovering 639.3 rupees at the end of the third year. And at the end of the fourth year, we will recover 1049.1 rupees. So we will be recovering 1000 rupees during the fourth year. So the years before full recovery is 3. So this is 3 plus unrecovered amount at the start of the period. So start of the fourth year, the unrecovered amount is the amount that we have already recovered at the end of the third year, subtracted from the amount that we want to recover. So 1000 minus 639.3, which is 360.7, divided by cash flow during the period. So cash flow during the fourth year is 409.8. So 409.8. So this is equal to 3 plus 0.88, which is equal to 3.88 years. So for project S, the payback was in 2.95 years as per the discounted payback method, whereas for project L, the payback will be in 3.88 years. So based on the discounted payback period method, project S will be given higher ranking as it is going to recover the investment outlay sooner.